Okay, so this is example 5. I'm just going to run through everything you need to do to graph this sinusoid. It has all the things, it has all the issues that you'll have to deal with. So the first thing you're going to do is you're going to factor out the coefficient on x. You're going to factor it out in the argument. So you're going to put it right there, and then you're going to rewrite the equation. So also, I'm putting the -3 that's at the end of the equation at the front, just because that's how I like to write it, because to me, it's less confusing. It doesn't make you wonder if that's in the argument of sine, because it's not. Okay, so that's how you factor the argument. So x has a coefficient of 1. And the next thing you're going to do is look at that -3. You're adding something to the function that's going to move the function vertically. It's going to move it down 3. So the midline, this time when you graph the sinusoid, is going to be at -3. That's going to be kind of like your new x-axis. All right, next thing, you can look at the amplitude. That's the number that is multiplied by sine, and that is 3. So that means that your function is going to go up 3 and down 3 from the midline as it goes. All right, next thing, you're going to look at the phase shift. The thing that's being added to x makes the function scoot over one way or the other, and since we're adding a +2, that means we're going to move the function 2 spaces to the left. So it's going to start over here at -2. That's going to be kind of like our new y-axis. Now we need to look at the period. So you have -pi/4, the thing that you factored out. Remember that the period is going to equal 2 pi divided by whatever that number is. So this, and then you get -8. But wait a second, a negative period, what does that mean? Well, thankfully, we don't have to deal with that because sine is an odd function. What does that mean? It's symmetric about the origin is what you would say. And so that means that f of -x is the same thing as negative f of x. So there's a negative sign on the argument of sine, which means that I can take that negative and just put it in front. I can put that negative there in front of the 3 sine whatever. Instead of having that negative in the argument, I can have it in front of the function. So I rewrite it as -3 minus 3 sine pi/4 positive this time, x plus 2. So I'm just moving that factor of -1 out in front of the sign, and I can do that because this function is odd. I can't just do that anytime I want to. I can do it because this is an odd function, so f of -x is equal to -f of x. So now the period is 8. It's just 8 because that number in front of x plus 2 is pi/4, and 2 pi divided by pi/4 is 8. So that means that in 8 spaces on the x-axis, this function will complete its full cycle, one full cycle. Also, one last thing I have to deal with is that negative sign in front of the 3 sine pi/4 times x plus 2. That negative sign tells me that I'm going to have to flip the function. If you put a negative sign in front of sine or cosine, that means you need to flip it upside down. That is a reflection across the midline. And so now, instead of the function looking like this, where it starts at the midline and increases up to the maximum and then goes down to the minimum and back up to the midline, now we're going to have to flip it upside down, and it'll start out at the midline, but it will decrease instead of increasing. So it'll look like this. I also want to figure out how I'm going to draw this with regard to the x-axis, so that when I draw my graph, I make sure that I spread it out correctly over the period of 8 spaces. And so 8 divided by 4 is 2. So every 2 spaces on the x-axis will represent a quadrant. So I'll start at the midline, like I was saying. I'm going to go down to the minimum because I normally would go up to the maximum. Okay, so here is how the graph would look, starting at -2, -3, because of the phase shift and the vertical translation down. So now I'm going to draw my graph. So there it is, one cycle, 8 spaces. in the right place, and that's what it looks like.